स्टाइलिश निकाल के नीचे रखा है, यहाँ पे नीचे नहीं रखा है इन लोगों ने, इसके अंदर है शायद, बोलना पड़ेगा।
ये है क्या?
हाँ यार
पॉइंटर नीचे एक ये होने से वो नीचे है।
वो तो ऐसे ही टेस्टिंग में
इट्स लाइफ।
आपको कुछ लिखना हो यहीं पर डायरेक्ट लिख सकते हो आप, ठीक है। यहाँ पर नीचे ऑप्शन आ जाते हैं मेन्यू, ये आ गए ना, यहाँ से आप पेन सेलेक्ट करोगे तो आएगा, पेन सेलेक्ट कीजिए एक बार, जो आपको पेन लेज़र पॉइंट।
हेलो हेलो हेलो।
morning, all of you. On behalf of DG Nectar, scientific and technical staff of Nectar, I welcome you all on day 2 of 3-week summer training program on Geospatial technology. This is again a brief about Northeast Center for Technology Application and Reach. We are one of the unique institutions in Northeastern India, set up by the Government of India for bamboo and allied activities, geospatial activities, water and flood management, communication and information technology applications, agriculture and food processing, livelihood development activities, and health and related activities. We had a vision to be the leading center to foster, nurture, and ensure the delivery, sustenance, and use of technology applications for public and social good, and to reach and expand the benefits of the technology among people, communities, institutions, and government for equitable and inclusive social and economic development of the northeastern regions. This is the agenda for today's session. So we will be having sessions on basic of optical remote sensing, which will be taken up by the Sri Rakesh Kumar Sharma, who is the speaker for today, and then followed by the practical sessions of both practical session of basics of remote sensing as well as basics of GIS that we have undertaken yesterday. So this is a very brief intro about today's speaker, Sri Rakesh Kumar Sharmaji. He is the Chief Coordinator Technical at Northeast Center for Technology Application and Reach, Nectar. And he has done a master's degree in geology from Cotton College, which is presently known as Cotton University. He is currently pursuing PhD from Cotton University. He is having more than 12 years of experience in various applications of remote sensing and GIS such as flood, agriculture, forestry, urban, and other sectors. He has a vast working experience in various government agencies such as NASA Institute of Disaster Management, Ministry of Home Affairs, Government of India, Northeast Center for Space Application Center, Assam Space Application Center, Meghalaya Basin Development Authority, and private industries such as Jinder Drilling and its Industries Private Limited. I request Sri Dharmendra Kumar Jhaji, Senior Analyst, to facilitate today's speaker in traditional Assamese style. Now I request our today's speaker, Sri Rakesh Kumar Sharmaji, to start the session. I now hand over the podium to him. Thank you all.
A very good morning, everyone. Myself, Rakesh Kumar Sharma. I have passed out from Cotton College in 2010. After that, I have done one postgraduate diploma program from Indian Institute of Remote Sensing. And after my academics, I have joined various organizations to learn the basics of remote sensing. I have worked different agencies, either private or government, and at least I have reached this position to deliver the basic of this remote sensing. I think I am eligible to tell something about this emerging technology. So initially I would like to know the background of your background. I have seen your profile, so basically you are from geography. Majority of you are from geography. So remote sensing is actually very a diverse subject. It's nowadays it becomes too much interdisciplinary. So initially I would like to tell you that if you want to go for higher studies, then you choose like what is your passion. You can go to any of the dimensions, like there are scopes for glacial studies, you can go for geomorphology, you can go for disaster management, like that. If you are preparing for some competitive exams also, like if you are preparing for civil service or banking, if you learn some of the basic softwares like Google Earth Pro, which I am going to show you, it will become very helpful. If you are planning to do your own business also, nowadays these geospatial things become so much prominent that you can learn this summer training. The basic things you learn from here, basic things you carry from here. Later, after maybe 5 years, you can use this technology to expand your business. So this is not like a very typical academic thing. So you can twist it as per your requirement. So in the beginning, today we have to cover the basic of remote sensing, and in coming classes there might be geospatial technology, and it will be an integrated type of thing. So it's not like that basic of remote sensing is different, GIS is different. So we just try to learn from in an integrated approach. So the very first definition of remote sensing is the science and art of obtaining information. This is the main thing. Obtaining information. Obtaining information, it may be an object, it may be an area, or it may be a phenomenon, but that information should be obtained not in contact with the object. Suppose we have a fever, we use a thermometer to sense the body temperature. So you can't say that one is a remote sensing. Actually, we should not have to come in contact with that object. Like in this photograph, the small children, she is watching a flower. She can differentiate the flower, she can differentiate the leaves, she can differentiate the grass without physically coming in contact. So the first remote sensing object we carry is our eyes. And our eyes is sensitive to we will come to the next, in a very limited portion of electromagnetic spectrum. Okay, we will come to next this one. The other remote sensing, suppose a cameraman is taking a photograph, he is not coming physical contact with those persons, and he is using a device. There needs to be a device to collect that information. So when a cameraman is clicking a photograph, that camera is the device. When a satellite is capturing images of Earth, then the sensor mounted in the satellite, this is the device. Similarly, nowadays the drone or UAV technology is getting popular. So the drone, we use that camera. So the camera is the device which is collecting those information. And this is a book. This is the book, Remote Sensing, and you can just click a photographs also. Otherwise, I can provide this one also. This is a book. This is available freely. If I will collect all email IDs from you, and then I can send this one also. This is a PDF book which is free. If you go through this book, this is like a Bible of remote sensing. Next is from the same definition, that obtaining information about object, area, or phenomenon. So this is an example of what remote sensing provides. So this image you see, this one, you might have come across this one also. This is nothing but Assam Secretariat. This is the road 2 years back in 2020, the only road you can see. In 2022, here you can see a overbridge. So bird's eye view means as if you are flying above the sky to see this entire landscape. That is the first bird's eye view. Then the phenomenon under temporal observation. That means repetitive coverage. If you see in a temporal scene in 2020, the scene is different. In 2022, the scene is different. So that is the beauty of remote sensing. You can temporally analyze things. Like here, this area, this building is remain This is the same building, but here some new maybe demolish activity or something is there. And another thing is, with the help of geographic information system, this is the remote sensing, and when you bring it in a software environment, then we can calculate the length of this overbridge, how many buildings are there, how many open spaces are there, how many tree clusters are there, like that, in in a very easier way. Initially, prior to the remote sensing, people has to go to the field to do this these types of activities to collect information. It involves lots of manpower, lots of cost. But the remote sensing, once it comes, after that, though, it becomes very cost effective. So this is another application, as you all are well aware, is that it's used in disaster management. Suppose pre-disaster condition and during disaster, when disaster extend, after post-disaster, this sea might recede here. So what is the impact? If you analyze, then you will see, suppose T0, this is suppose T0, this is here T1, and in T2, post-disaster, you can analyze what are the damages happened by this phenomenon. Similarly, what are another aspect of remote sensing is to gather information on inaccessible places and environments, like Himalayan snow peak. These are the snow peak area. This is a glacial lake. These are quite inaccessible. We have to, if we send manpowers also, it's very risky in these types of terrain. Here in volcano, you cannot go here and just click a photograph. So these types of analysis is very easy using remote sensing. Then this optical remote sensing. To understand remote sensing, we have to understand the phenomenon how we see. Suppose in this room itself, we are seeing each other. Why? Because the light is here. If we go outside, what is the source of that light? That is the sun. So sun is the source of all the energy. And what is light? The phenomenon of light, to understand what is exactly light, so these are not decades, it's all about the centuries of research. Many researchers, they want to understand what is light. Light, some of them say that it's a wave. Then later they understand that it is not only wave, but it has the particle nature. So basically, light is an electromagnetic spectrum. It has one electrical field and perpendicular to that one magnetic field. Now to understand these things, electrical field means what? Electrical field, it's like when there is, suppose current, how current flow in a wire, when there is a vibration of electrons, then we will get the current, and perpendicular to that current, that flow direction, one magnetic field generates. So this is the one of the basic principles of physics. So the entire electromagnetic spectrum from sun, we are getting this entire electromagnetic spectrum. This electromagnetic spectrum, though it varies, we make it vary based on our convenience, but actually the basic principle is same. It's the interaction of wavelength lambda, which we call, and frequency nu. So one basic equation of physics is C equal to lambda nu, where the C is constant, that is the speed of light, which is a constant. So if wavelength increases, that means there is a decrease in frequency. So in the visible spectrum, this is the entire range of spectrum. Here only a minor portion, if we see this entire graph, here only this portion is the visible light that God has gifted us, or it's because of the evolution we only sense this thing. In the next slide, okay, so this part is very interesting. We have to understand this part to appreciate the phenomenon of remote sensing. This part, suppose snake. So snake is sensitive, according to some of the research, that some mosquito, vampire bats, bed bugs, and some snake can use the portions of infrared for their vision. Okay, this is the data from National Geographic. So they use a particular infrared region. This region, we are use only visible portion. So FIB0 we know. So this is the infrared. This region, some of the species they use for sensing. So if we can develop certain type of camera or some technique so that we can sense that infrared, so we can see some of the other dimension of things. Suppose an example is tree. So tree we usually see tree as green, but in comparison to green, tree reflect more infrared energy than green one. But we cannot see that because our eyes are not gifted enough to see that one. But some other animals or some other species may see the tree in a different color. Suppose in the night time, you might have that some animals make different types of sounds. They have seen certain things which we can't see because that sense that part of electromagnetic energy, and we sometimes we call, oh, that ghost is appear. It's not a ghost actually, it's some part of that electromagnetic energy which that particular species have sense and making some sound like that. So this is the basic idea of remote sensing. So here in this entire range, if we see, this is a radio wave, then radio wave which you can see this, that these are the frequencies. So radio wave, they have lambda is greater than this portion gamma. So we know lambda and frequency, these are inverse. That means if its wavelength is high, its frequency is less. So these radio waves we are used for radio communication. Similarly, within this electromagnetic spectrum, optical remote sensing is concentrated only on this visible portion. Then infrared also, it's a major spectrum, major portion of the spectrum. This is infrared, and from that infrared, it has one component of thermal energy. Nowadays, all these new concepts are coming up. Urban heat island. So what is actually urban heat island? Urban heat island is nothing but the thermal energy. This is the thermal energy emitted by the this concrete objects or whatever. In more the concrete as things will increase, they will increase the radiation in the thermal portion. So if we develop one sensor which can sense this one, which can collect this energy, So we can measure it, that how much energy is reflected. Suppose here a small village is there. Suppose this is Guwahati we are sitting, maybe in urban area where the thermal reflectance is less in comparison to this concretized one. So here we are getting less temperature. So based on that, one sensor is there which is called moderate resolution imaging spectroradiometer. It's called MODIS sensor. So MODIS sensor, they calculate the land surface temperature of the entire globe, and based on that we see those news that heat waves are coming in this mainland, this portion. Heat waves are approaching, there is a glacier are reducing. So all this analysis, all this scientific documentation, the basic reference is this one, land surface temperature. From that satellite derived data only they used to make all this interference, that heat wave is approaching, this area is getting hot, glacier is getting glacier starts melting, and all these things. Then another within that spectrum itself, X-ray. Suppose X-ray, just for your information only I am sharing this one. So this is a journal, Elsevier's journal. Here it is published that at microwave remote sensing of Jupiter's atmosphere from an orbiting spacecraft. So this remote sensing activity is not limited for Earth only. These are the other planets also. Nowadays all those news are coming that new satellite is launched for say Mars. It's not a new news, but for some other planetary remote sensing also. So they might not use optical, but the microwave part they are using. From that microwave energy only lots of interference can be made. So we are speaking about this optical remote sensing. So here the basic source is sun. So these types of remote sensing is called active remote sensing, because here these types of remote sensing is called passive remote sensing, because the source of energy is different. Source of energy here is the sun. So the sensor mounted on this satellite, that sensor is using sun's energy, so it is called passive sensor. Similarly, some of the sensors are there which have their own source of light or own source of illumination, and those types of sensors are called active sensors, as for example LIDAR or SAR. SAR is synthetic aperture radar. So these types of satellites, they have their own source of illumination. They used to send some pulses and they measure the return beam, and based on that there are certain process, the processing scenes are there, and all these things will be covered in upcoming classes. So based on that finally we can derive some of the images, like this one is a SAR, synthetic aperture radar derived image of water bodies. So what is the advantage of active remote sensing? Advantage of active remote sensing, suppose in passive remote sensing, this is the sun, this is the terrain. So this is, we are telling about the condition of Assam during monsoon time. So what will happen here? Cloud will come. So in the image we will get nothing but cloud, and the district administration has to take the decision that how many villages are flooded. And using optical remote sensing we can get nothing but the imagery of cloud. We can't take any decision. So in these types of situation we have to go for in these types of situation we have to go for synthetic aperture radar or radar imagery to get rid of this problem. Then next is how the energy is transformed into an imagery. So actually satellites, they have some CCD device. Okay, so this device, what it do, it used to scan as the satellite proceeds, it used to scan like normal scanner. So based on that information, so that data, it used to be sent to the ground receiver station. So our ISRO has a ground receiver situated at Bangalore, one is at Lucknow, Mauritius, and Sriharikota, Port Blair, etc. That's why ISRO is playing the global role in this satellite technology. So that energy, once this receiver receives, so this using high capacity this computational system, it is converted to satellite images. That means the digital numbers, they are finally converted to satellite images based on some processing. So this satellite images is constituted with the pixels. Pixel means, we all have that experience that when we click the photographs, it comes in elements. It is like a array of cells. So a pixel, it has an intensity value as well as the location address. When satellite captures the energy, so it has one intensity value. Based on that, we can predict many features, and it also has a locational address. Suppose I am showing an example. Here we are clicking here in this point, so this is the latitude and longitude information. Similarly, if we click here in this point, the latitude and longitude information is different, and they have certain intensity values. And different features on Earth surface, they behaves differently with the range of electromagnetic spectrum. So from that, it is a graphical representation of the spectral response of an object over different wavelength of the electromagnetic spectrum, that is termed as spectral reflectance curve. This curve is very much important in remote sensing. Whatever you go for a higher studies, always you will have to understand this particular curve. Suppose for this particular type of forest, conifer forest, this is the graph. That means in between 0.4 to 0.7 micrometer, this is the range of our our visible spectrum. So in this range, you can see here is somewhere, peak is here, and beyond this 0.7 micrometer, it increases like anything. Actually, these are the nothing but infrared energy, which is reflected from trees. And whenever we see any remote sensing image, we will always focus on, for vegetative study, for forest related study, we always have to focus on infrared channel. Then similarly, soil has different characteristics. Water, since water absorbs a lot, if water body is there, if solar energy is incident, it always get absorbed, lots of energy get absorbed. So the particular graph is showing like this. So based on that, you have to analyze different features based on this particular graph. So this is very important, spectral response curve. I will send you that PDF. You just read all those things. Spectral response curve. I am just trying to highlight the key components of this basics of remote sensing. Then another aspect of remote sensing is that we can get the elevation information. In this particular satellite image, this all the point, if we click any of this point, we'll get the elevation information. So these are the higher peaks. If you can see in the scale, these are like 3000, maybe 3000 meter. So the height of this one is 3000 meter, and these areas are the plain areas. So if you do for flood related studies, so you know that water is coming from this area and finally accumulated here. So you can do your flood management based on this one, as well as other urban, or if you want to make a new city, you want to develop a city which is safe for this water accumulation. So based on this analysis only, based on this information of elevation, you can do all these sorts of decision making. So this is a digital elevation model. You just note it down. Digital elevation model is nothing but the topographical surface, elevation of this topographic surface of Earth, excluding trees, buildings, and any other surface. This is the elevation information of the bare Earth. So some of the example is this one, SRTM one dam is there. So suppose now the concept of smart city is coming up. So smart city, if you want to analyze that whether the Anil Nagar, Nabin Nagar, all these areas always get flooded. So why? If you as a remote sensing expert, or tomorrow you might be joining some this urban development department. So if you have to analyze all these sorts of things, where does water is accumulated, actually where initially we should design that proper drainage. At that time when Guwahati city was developed, there is on this remote sensing concept is not there. It was developed haphazardly. So that's why now we are witnessing all these sorts of problems. So if you have to take a wise decision based on this technological tools, so you have to use all these things. One of them is a digital elevation model. So these are the example. SRTM is an it's an open source digital elevation model data. Similarly, our own Indian satellite, we can get this CartoDem. This is derived from the Cartoset imageries. So pixel I have already covered. Next topic is the resolution of a satellite imagery. What is resolution? All of you already know. We used to watch YouTube videos. We can increase the resolution, we can decrease the resolution, but in YouTube videos, if we use 144 is a less resolution, but here it's the concept is different. Suppose this is one example of Landsat imagery. Landsat imagery, it has a spatial resolution of 30 meter, and this is our Indian satellite LIS-4. It has a spatial resolution of 5 meter. So what is spatial resolution? Spatial resolution means within this area, as I have mentioned in the yellow box, the number of pixels present. Higher the spatial resolution, meaning more details can be observed. For more details, we need more pixels. So this is an example of Guwahati Airport. So using this LIS-4 imagery, you can see it's much more detailed in comparison to the Landsat. Sorry. Suppose we are talking about Landsat having 30 meter spatial resolution. That means anything which is less than 30 meter, you cannot differentiate it. It will come as a single pixel. Any object which is greater than 30 meter, only you can differentiate that one. Similarly, if you are using LIS-4 image, any object which is greater than 5 meter, that only you can differentiate. And nowadays we have this Cartoset satellite. and resolution is increases up to 0.5 meter, and these are used for military purpose. And cartoset you can purchase it from NRSC website. That all these things will be covered in later classes. Next resolution is spectral resolution. So the spectral resolution, to understand this one, we have to understand it signifies the bandwidth in which the sensor collects the information about the scene. So these are the following are the different bands of Sentinel-2. Sentinel-2 is a satellite which is launched by European Space Agency. Okay. So like we have ISRO, the European there are European Space Agency. So in Sentinel-2 we have almost 13 bands, spectral bands. Now what is spectral bands? Spectral bands means these are the range of electromagnetic spectrum which can be sensed by that particular sensor. Suppose there are 13 bands. Suppose this B2 is a blue band. So it will sense that energy which is central wavelength is 490 nanometer and bandwidth is suppose 65. So plus minus 65. In between 490 here plus minus 65, this is the central value. Similarly for suppose near infrared we have this 842 nanometer and its bandwidth is 115. So in this central wavelength is 842. So it will lie somewhere here, not here. Suppose blue one is 490, so it will lie somewhere here, 440 somewhere here. Then suppose green is your 560, so it will lie somewhere here. So that particular satellite Sentinel-2, it has that sensor which can sense in all these bands. That is the main idea. So based on that, it is our requirement which band we are going to use. For example, just I want to show you one example. This is the Google Earth imagery as reference. All these things I will cover. Google Earth imagery, this is the freely available, every one of you using Google Maps. One software is there, Google Earth Pro. Okay, this is an open source software. You can download it for your visualization, area calculation, etc. If you are planning to do future PhD or something, you just remember this software, Google Earth Pro. You can do a lots of decision using this Google Earth Pro. Simple map making also you can use this one. So this is a Google Earth imagery. This is Brahmaputra river. This is a water body. You can see these are the vegetation patches. You can see these are the settlement layers. This is a road. There are some open spaces. This construction activity is going on. Now, using this concept, spectral resolution signifies the bandwidth in which the sensor collects the information about the scene. So I will like to explain how we can see this same image in different bandwidth. Suppose we are using band 2, and band 2 is what? Band 2 is blue. So this is blue. So like, just imagine that we have a capacity to sense, like the snake example I am giving, which only sense this blue portion, this blue portion, this portion. So we have a sensor, it only senses this portion. So the images is coming like this. All these images are coming in black and white, and we mix it. Like white color is what? There are different components. VibGeo we have studied in our high school time. So using a prism, if we use white color, it will give us the entire spectrum. Similarly, if we split different things, it will become black and white. So only blue, it looks like this one. So here we can't interfere any information. Suppose water body here, this is the water body here, it's not, we cannot demarcate using this blue band. Only some of the reflectance in here, some new urban structures are going on, some of the construction sites or something is there, only here some blue. So only here some of the reflectance are here. But if we go for B4, what is B4? B4 is the red band. So here we can identify some of the feature. So here these are absorption, here the total absorption, here some reflectance. These are the bright, these here some reflectance in the middle range. So it's like that. So then again if we go for B8, B8 is our near infrared. So if I see a near infrared image, you see the vegetation patches. So vegetation patches, they are showing not that much dark, but a little bit lighter this shades are there. So in comparison to the blue band, you can extract lots of features using this B8 band. So you can correlate that one with that graph initially I have mentioned. A particular feature, suppose this particular feature, in blue how it behaves, in infrared how it behaves, based on that graph is drawn, and that graph is called spectral response curve. This is B11, this is short wave infrared. This is a bit blur, but in many studies like some geological studies, this B11 is used. So like that, so we are having the information of all these individual bands. Once we make a composite of all those bands, we can get colored image. And that phenomenon is also happening with us, because whatever colors we see in and around, it is nothing but the composite of this Fibgeo, this composite of this entire range. For our convenience, we are segregating it. This is violet, this is indigo, this is blue. But this is a very continuous spectrum with very finer differences in the grading. So if we combine red, green and blue, these are the primary colors, and other colors are nothing but the mixture of this one in different proportions. So if we use blue, red, green and blue, we can see, or you can visualize in GIS environment these types of image, and this image, since it resembles to our the natural color, so it is called natural color composite or true color composite. We can play with this different band, we can make different composites. So based on that, our visualization will be different. Suppose this we are seeing natural color, but here the contrast is less. If we add here one infrared channel, then the situation will become different. Here we are using NIR red and green. We are replacing the blue band. Here you can see the enhanced feature. We can see the enhanced feature. We are seeing this red patches. These are nothing but vegetation. Why we are seeing it red? Because trees, they used to reflect more on infrared side. That's why we see it green, but it reflect more in infrared side, that I have already mentioned. So these patches we can easily demarcate. We can easily demarcate these types of cyan color as settlement. Using GIS, just one click we can determine the entire area of this settlement. entire area of this, suppose agricultural land, entire area of this anything, length of the road we can measure. We can calculate the density of this urban settlement with the total area. What is the dense, how much dense? If we use temporal images, suppose this one is T0, after 10 years if we take images, then we will see that these patches are also urbanized, these patches are also urbanized. So like that we can analyze anything. So next resolution is the temporal resolution. So in temporal resolution is nothing but the time between two successive image acquisition over the same location on Earth, and this is very important for disaster management point of view. Suppose this is an example I am showing, satellite image of Haiti earthquake before and after. You can see this building which get collapsed. This is only because the satellite is revisiting the same spot again after few days. So that revisit time, it will is a function of actually different parameters, orbital height, SWAT, and all those things are there. So this Landsat image, they have temporal resolution. That means after 16 days you used to visit. Suppose Assam Science Society building we are sitting, and today it is visited, then on the same location it will come after 16 days. So this is the temporal resolution. MODIS sensor has temporal resolution 1 or 2 days, and MODIS sensor is mainly used for, I have shown you at that time, land surface temperature and other. MODIS helps scientists to determine the amount of water vapor in column of atmosphere and the vertical distribution of temperature, water vapor. So it makes the understanding the Earth climate system. So based on that, the decision makers take the decisions that how the climate is behaving. So this is the temporal resolution. Then next is radiometric resolution. Radiometric resolution is like the ability of the sensor to differentiate the change in energy. That means how much sensitive the sensor is. If it's 1 bit, then it can differentiate only two parts. If it's 4 bit, then it can differentiate 2 to the power 4 up to 16 part. Similarly 8 bit, so it is up to 256 parts. So if its radiometric resolution is high, we can get this segregation of the same electromagnetic spectrum in the different sets, or we can get more details. Okay, till now it's fine now. The next concept is about the type of orbit. Now the question is, suppose one cyclone is approaching, and as I have mentioned, if the satellite, suppose this is a coast of Odisha, one cyclone is formed here. So to replace those people in the coastal area, or the decision maker, or the disaster response people, to respond properly during that disaster, so they need continuous information about the cyclone, how it's proceeding, what is their path, in which coast it is going to hit. So if we use the previous remote sensing concept, like only after 6 days it will come, only after 12 days it will come to the same spot, so we cannot rely on those remote sensing satellites. So in these types of case, we have to rely on meteorological satellites. So meteorological satellites, and as well as the communication thing. If we have a communication antenna here, if the satellite goes somewhere here, all the time it's changing, then we have to always rotate that antenna as per the rotation of the satellite. So it's not it's visible, but it's not always the proper relevant. So we have to devise certain other remote sensing techniques so that we can continuously monitor that cyclone, how it's approaching, which course they are going to hit. So for that, these types of satellite, we have to launch the satellite so that it will reach in certain point, so that it has to constantly monitor the same point on the earth or same area of the earth. So if earth goes here, satellite has to move this area. If it goes here, so the satellite has to move here. So the revolution of the satellite has to be adjusted so that it will be same as the rotation of earth. So based on that, it will continuously monitor a particular area or particular phenomenon constantly. So based on that, we have these INSAT satellites. INSAT. So in newspaper also you find that based on that INSAT satellite image, this weather prediction, this cloud movement. So this INSAT is Indian National Satellite System. INSAT is a series of multi-purpose geostationary satellite. These are geostationary satellite launched by ISRO for telecommunication, broadcasting, meteorology, search and rescue operations, etc. So for that orbital height, first thing is that the orbit in which the satellite is placed above the equator, it has to be placed above the equator, and the distance should be 36,000 kilometers. So these types of orbit is called geostationary orbit, and the satellite, we use meteorological satellite to place in the geostationary orbit to get a constant view of a particular location or phenomenon. Then second one is the remote sensing satellite. Remote sensing satellite are low earth orbit satellite. So these are the meteorological satellite. These we can say that the high orbit, and this remote sensing satellites are low earth orbit, in between 200 to 1000 kilometer. And we have two types of orbit, one is polar orbit and one is sun synchronous orbit. So polar orbit, it will be from pole to pole, they revolve from pole to pole. So in sun synchronous orbit is a particular kind of polar orbit which passes by any given point with the same local solar time, which is useful for consistent lightning and sun angle. Okay, so the sun synchronous orbit, it passes by any given point with the same local solar time, and which is very much useful for remote sensing purpose. So majority of the remote sensing satellites are sun synchronous. They are placed in between 680, 700, like that, 700 kilometer. And this meteorological satellite, you see, 36,000 kilometers. So this thing, I hope it's clear. The next important part is downloading open source satellite images. This is very much relevant for your future study. Or open source means these are the freely available sources from which we can extract data, we can download data freely, we can visualize data freely for all our applications. And one of such freely available platform is Bhuvan. This is a geo platform which is developed by ISRO for data. We can access data, we can download some of the maps freely. If we want drainage layer, if we want land use layer, if you want water bodies, if you want soil map, everything you can download from Bhuvan portal. And in that practical session, we will show you how to download and how to visualize. In that Vuban portal, if you there are different themes address, so thematic services. If you explore in the thematic services, you will get lots of information. Land use, you will get urban land use, wasteland, glacier, lake, geomorphology map if you want for free, linear man map, flood hazard, water bodies, urban sprawl. Select geography option is there. You just have to put the geography. Suppose you want to extract information for Kamrup Metro, automatically Kamrup Metro, all the layers will come. If you want to visualize for say Dibrugarh, you just select geography Assam Dibrugarh, all this, whatever data you want, it will come for the entire India. So this is, suppose I am giving example Assam, you click Kamrup Metro. So these are the land use, land cover up to 1:10,000 scale. So you can easily extract from your any kind of study. It's a readily available map. Here you can urban, these are the urban, this red patches are urban, then these are agriculture, yellow one. This green are some forest cover, or those hills we see. Then here you can download some free satellite imageries also. Suppose this resource set list 3 image you can download from here. You can download this Cartoset 1 dam also you can download. Then this resource set advanced wide field sensor. These are the satellite products you will get. You can download and analyze. These are totally free. You just have to do one login. Like this, we will show this one in the practical classes. You have to suppose it will come like this types of tiles. You have to do some you have to just select those tiles to download this one. Automatically those options will come, and in which period you want to take that image. Suppose in monsoon you will get only cloud, during the winter you have that cloud free imagery. So all this selection you can do using this select area option. Another important platform from where you can download is the Art Explorer. Okay, this Art Explorer, this website is maintained by United States Geological Survey. So from here you can download almost entire lots of global imageries. Everything is available. Landsat images is available here. Radar data you can use. Sentinel also. Then Indian remote sensing satellites also you can download. The digital elevation data, as I have shown you in the previous slide. All these things you can download from Art Explorer. Similar website is Copernicus Open Access Hub. So this also gives complete free and open access to Sentinel 1, 2 and 3 products. So this is developed by European Space Agency. And this is the Google Earth Pro I have mentioned you. So Google Earth Pro is also very helpful in analyze. This is a screenshot of this Google Earth. Here if you search the name of any area, it will automatically highlight. Suppose I have searched there Assam Science Society, automatically it will come. Here one button is there historical. This will show you. Here you can access the historical images. So this image is the current image. This 2004 image I can cross check that what is happening here in the Assam Science Society area in 2004. You can see many of the new buildings are come up. Suppose this one building is coming up. Here there is only construction work is going on. So like that type of analysis you can do free of cost. Here if you go to tools, their options are there. Polygon, you can make your own polygon, you can measure distance, you can export, you can frame your own map, and after that you can export this one. So all these things you can do using, these are the open source platforms available. So I hope I can give you some sort of fundamental things about remote sensing. Is there any questions or queries? Actually, this open source software are very helpful. I have told you, like, if you are preparing for some competitive exam, suppose you are studying history, you want to know the route by which some of the suppose Mughal Empire has entered. You can search in that. You just search in which way they have entered, how British has come, where they have made the colonial rule, and particular suppose food habits. These types of suppose I am giving you example. Here suppose lots of bamboos are available. So there might be chance that this entire population they will depend upon bamboo. Suppose it is a coastal area, so those people food habits and their culture, everything will be dependent on the coastal this landscape. So based on that you can analyze your for other aspects also. If you won't go for higher studies, whatever discipline you opt in your future, so you can use all these softwares. If you do business also, few days back one of my friend has called me. He works in some this second-hand car dealing. He called me. He's just telling me that I want a map of this newly urbanized areas of Assam, so that we can make some delivery center there. So that in that business also nowadays this geospatial technology is integrated. So whatever discipline you go in your future, if you have a practice of using this spatial science, somewhere you will be benefited. Okay, with this I would like to complete and thank you all.
Good evening. If you have any doubt, jot it down.
I think in practical classes things will become much clearer, because remote sensing, it's like it's a tool which we are using our hand. So it's not like explaining a theory part. If you do of your own, then only things becomes much more clear.
If you have any doubt, you can ask now. You can keep it with you also. By evening, you can ask. If you have any doubt, right now.
How many of you are interested for pursuing this remote sensing in your future PhD or in higher studies? Okay. So currently you are doing masters. Okay. Now what you are doing? Acha, acha, acha. And you? You are still doing your masters. Completed. Acha, acha. If you want to pursue higher this one, so Indian Institute of Remote Sensing is one of the good option. They provide MTech. They provide this one MS course in collaboration with University of Twente, Netherlands. So in that one course itself, you can visit Netherlands also for 3 or 4 months. And after that, if you are more interested in pursuing that higher studies, then they will provide you this scholarship opportunities for PhD or some other research program. So many of my friends are now they are situated abroad. So this is a very good option. Other central universities are also there, but you have to complete your PhD. After that, it's best if you do your postdoc or some other things. And those who are preparing for other exams, also bank or public service commission also, if you go through these types of software, these are very freely available, and if you correlate your studies with this geospatial if you bring this geospatial knowledge in your other studies also, you will become benefited. Okay, then thank you. Actually, urban heat island, for that, what you need? You need the temperature information, right? Temperature information is, okay, I will show you one thing. So this is the electromagnetic spectrum. So here this is the visible portion, and you see from ultraviolet from here, suppose in the visible from here, you see this portion is very limited, and this near infrared, this mid wave infrared, this range is quite big. Our remote sensing is only limited to this optical. This is called optical remote sensing. If we do remote sensing in this region, we call it optical remote sensing. But we are speaking about this thermal remote sensing. For urban heat island, we have to concentrate our remote sensing on this portion mainly. For that, there are certain satellites, as for example, I have given you one example, MODIS. So from MODIS, this is, you can access the LST or land surface temperature for the entire globe, and this is an open source software, so freely you can avail the data. Then another sensors are also there which works in the thermal range, Landsat enhanced thematic mapper, plus they also have that thermal sensor. Many of those satellites have that thermal sensor. Then you have to concentrate your entire study in this portion of remote sensing to understand this urban heat island. So urban heat island is what I have already given you one example. Suppose this example. So we are using, this is a LISFO image. This is a LISFO image. I will show you. Cannot do this. Sorry. Suppose this image. This is a LISFO image. From here we get this locational information. We know that these areas are urban settlement. Okay. These are some swamp type of thing. This is the Guwahati airport. If you have seen this site, these are lots of swamp areas are there. These are the vegetation. These are again those urban clusters, settlement layers, some concrete building, business establishments, etc. To study urban heat island, if you use suppose the MODIS sensor, then from here, like this portion, if we zoom, so it will show like this. So these are the pixels. So each pixel have a latitude longitude information, and from MODIS data you can get the temperature information. Suppose you are using MODIS data, you can use the temperature information. Suppose you are using one digital elevation model in the same platform, you can get its elevation information. And you are using this optical sensor or MSS, these are LISFO image, suppose you are using, you will get this latitude, longitude as well as the intensity. Suppose you are considering the lat long information. So this particular pixel at certain elevation, the temperature you are getting this one. So if you go for a temporal remote sensing, suppose you 10 years back you have get the land surface temperature data, maybe after 10 years you are analyzing the same area using this MODIS data, you will get the difference in temperature. Or you can do some types of density analysis also. Suppose 10 years back these areas are green vegetation are there, maybe open spaces are there, maybe agricultural lands are there. So at that time your temperature is different. Now because of this urban agglomeration, the temperature increases. There are other data also, aerosol data, etc. also you can incorporate in your study. Aerosol data or the pollution data. Suppose you add that pollution data. Last 5 years back pollution is this much, now the pollution is increasing, and urban construction is also increasing, and all this multiplying the heat heat effect of the city. Okay, I will send you this PDF book. This will be very helpful if you go through. And internet also you will get lots of literature, lots of data regarding this.
So the last day we'll give all these resources.
Okay then.
Anyone, any doubt?
In the practical classes we can explain more detail.
Actually, he is a bit late. He's not arrived yet. So we have to wait 5 more minutes. Sir, आप यहाँ जाइए.
Okay.
If you have any doubt, any kind of doubt you can ask.
You put on the mic to speak. ये भी on सारे on.
ये ऑफ कर दीजिए.
I was asking about, like, can you explain a bit of CCD and its full form?
Hello. CCD. So it's like it's like square shaped electronic device. So they can sense that energy. So it's you can search this one in internet. Push broom sensor and whisk broom sensor. Okay. In that book also it's available. Push broom sensor and whisk broom sensor.
Any other doubt? Sharmaji.
पंद्रह जी का तो ऑफिस में बता दें.
टेम्पोरल रिजोल्यूशन तो क्या बुझाइदियो.
हाँ.
टेम्पोरल रिजोल्यूशन तो क्या बुझाइदियो.
Temporal resolution. Temporal resolution is, suppose this is Earth, this is the satellite. So it used to rotate, na. So after few days it will come to the same place again. After 16 days maybe. It's not. It used to come to the same. Suppose in Guwahati itself, suppose this building itself, it will come after few hours, but not in that same point. After 16 days only it will come up to the exact point. That is the temporal resolution. I'm not getting that.
Basically, temporal resolution. If a camera is clicking, it's simple. Just I'm clicking this picture of this board now. And after some time or half an hour, I'll click the same picture from same place. That is temporal resolution. After that is called a satellite revisit. आज गुवाहाटी के ऊपर एक सैटेलाइट घूम रहा है, ठीक है, तो वो कल भी नहीं घूमेगा, वो उसका एक रिविजिट टाइम सेट होता है. तो गुवाहाटी के जैसे लैंड सेट है, वो 16 डेज के बाद वो रिविजिट करेगा गुवाहाटी. तो वो जो 16 डेज होता है वो होता है उसका टेम्पोरल रिजोल्यूशन. अभी भी नहीं.
मैं उस तरह से रिजोल्यूशन तो हमको समझ नहीं पा रही हूँ.
एक्चुअली रिजोल्यूशन कि एक ही जगह का वो इमेज कितने दिन के बाद ले रहा है. टेम्पोरल हो ही गया ना, टाइम पीरियड, कितने टाइम पीरियड के बाद वो ले रहा है टेम्पोरल. एनी अदर डाउट? कैन एनीवन समराइज द सेशन?
Carto DEM. Carto DEM actually Indian this space research organization, they have this Cartoset, one satellite is there. Okay, so using that Cartoset satellite only, this digital elevation model, actually the satellite cannot measure directly the elevation. There are certain mechanisms, some algorithms are there. Once so it will depend upon the tilt angle, etc. Lots of technical things are there. So they first collect those information using those Cartosets. Actually, there are two types of MODI sensor. One is Aqua and one is Terra. So Terra
you explain again this bandwidth?
That is called a bandwidth. Bandwidth we can it's up to our, we can customize as per our requirement. Okay. So blue it's not, it doesn't have a crisp boundary. It's like gradual, this grading is there. It's not like that from here to here it's blue. It's not like that. It's a gradual this transition.
Any more doubts? Any more doubts? Can anyone summarize the session? शर्माओ नहीं, बोलो, कुछ तो बोलो. And I have to bring that list and I have to ask by name only. Attendance sheet is there. From that side.
You are with us for 3 weeks, you will learn your names also.
Huh? Saila, start. Just summarize the session.
We have already remembered a few names.
And I have to ask about yesterday also. Whatever you learned yesterday, that I need to ask. First today, summarize today's session.
Whatever you have learned in 2 days, all the theory, we will be moving to the practical sessions of both the theory parts. But before moving to the practical, we need to be very clear with the theory part, or else you won't be able to understand what we are trying to do in the practical itself.
Yeah, it's a vice versa also. If you learn practical,
Both.
then you can appreciate this one.
So you need to be very clear with all those resolutions that sir has told about spatial, temporal, radiometric.
Saila?
क्या होता है?
Summarize करता है. Saila, just summarize the session. Or I'll ask the questions if you understand everything.
So today day 2 of our this internship program. First of all, these are all new things for me because I belong from civil engineering background. So, but at least I'm learning day by day whatever sir is he teaches us just now. So first I know about this remote sensing, um, um, which sir said that it is the phenomenon through like analysis of data acquired by device that is not in contact with the object or area or phenomenon. And next is this remote optical remote sensing. Uh, and sir already told us about this land surface temperature, which is the first time I heard about this, the moderate resolution imagining spectrum or spectral radiometer. And we have this digital elevation model, which is the representation of the uh, topographic of the earth, including excluding trees, buildings, and any other surface object. We have this spatial resolution, spectral resolution. um, and sir told us about this